and hi everyone. So in this video, we are going to take a look at the second subtopic in chapter 3, which is binomial expansion. We have four course frameworks. The first one is to find the expansion of a plus b raised to the power of n. So in this case, we have n is restricted to only positive integers, meaning we can just rewrite that condition as n is an element of z positive. And we are also going to use Pascal's triangle in our expansion. So the second course framework is to write n factorials. So this is factorials notation and using NCR, which is n choose r, as our binomial coefficient. So this is from combination. And then for the third learning objective, we are going to determine the general term in a binomial expansion, where we are going to focus on a couple of different cases. The first one is when we are asked to find the coefficient of a certain term in binomial expansion, and the next one is when the question asks us to find a term such as terms that are independent of x. For the last course framework, we need to determine the expansion of 1 plus x raised to the power of n for when absolute value of x is less than 1. And we know that n is a rational number. So again, we can just rewrite this as n is an element of Q, where we can write n as a fraction p over Q. So let's move on to our first learning objective. The first one is to find the expansion of a plus b raised to the power of n, where we have n is an element of positive integer. So before we start with the expansion, we need to focus on this one. This condition states that n must be positive integer, which means n can only take the values 1, 2, 3, 4, and so on, as long as the number is positive and it's an integer. So before I start with n is equal to 1, 2, 3, and so on, what I'm going to do is I'm going to start with a plus b is raised to the power of 0. So in this case, we have learned in the first chapter where any non-zero number a raised to the power of 0 will give us 1. So that's what we are going to have here, 1. As for the second example, if I have a plus b power of 1, my n is equal to 1 here. So there's no difference here. And what we are going to get is a plus b. And we know that our coefficient here is 1 and 1. Now, what if I give you a plus b squared? For this one, you have learned in school that we can rewrite this as a plus b times a plus b. And when you expand that, you are going to get a squared plus ab plus b times a is also ab and plus b squared. So since we have similar terms here, which is ab plus ab, we are going to simplify our answer. That will give me 2a squared plus 2ab plus b squared. So again, let's take a look at the coefficient. The coefficient for this expansion is 1. And then I will have 2 here. And then this one is also 1. Now, let's take a look at the expansion for a plus b cubed. So when I have a plus b to the power of 3, what this means is I'm going to have a plus b times a plus b times a plus b 3 times. And you need to expand each and every one. But I can also rewrite this as a plus b squared times a plus b, which means I need to use whatever I got earlier, which is a squared plus 2ab plus b squared, and multiply that with a plus b. And then again, we need to expand. And what you are going to get here is a plus b cubed is actually equals to a cubed plus 3a squared b plus 3ab squared plus b cubed. So if you are not sure how I got this, you can just expand manually one by one. And now let's take a look at the coefficient that we have here. The coefficient is 1, and then I have 3 here. And for the third term, I have 3 as well. And the last one, the coefficient is 1. Okay, up till there, I hope there's no problem for you to expand that. Now let's take a look what if I have a plus b raised to the power of 4. Do I need to expand manually like just now for the power of 1, 2, and 3? The answer is no, you don't need to do that, because in this case, when you expand one by one, what you have here is a plus b times a plus b times a plus b times a plus b, 4 times of a plus b. So it's going to be quite long for the workings. So before I introduce you a simpler method on how to expand this question, okay, let's just observe the pattern from the 3 expansion that I have just shown you. So the first one, let's observe our coefficient. When I have n is equal to 0, then my coefficient here is 1. When I have n is equal to 1, then my coefficient is 1 and 1. Okay, the one I highlighted in blue is my coefficient. And when I have n is equal to 2, then my coefficients are 1, 2, and 1. As for when I have n is equal to 3, then my coefficient is 1, 3, 3, 1. So what are the patterns here? Just pause this video for a second and think. Okay, so we can name this as the properties of our expansion. Now, if you observe, the pattern here is that the coefficients of the terms after we expand them is symmetrical. Okay, so I'm going to write it here. What do I mean by symmetrical? If you take a look here, for a plus b cubed, then my coefficient starts with 1 and then ends with 1. The middle term, the coefficient is the same, which is 3. So I have 1, 3, 3, 1. Okay, now let's take a look at another properties that we are going to have here based on what we just expanded just now. So if you take a look at the power for a and power for b, I'm going to start with a plus b power of 1. There's no difference, both power 1. But what was not written here is that what I have here is a raised to the power of 1 and b is to the power of 0. And for this one, I have a to the power of 0 and b to the power of 1. So if you take a look properly, a starts with the highest power, and as the term goes by, my power decreases by 1. And for b, it starts with the lowest power, and then as the term goes by, the power of b goes up by 1. Same as for a plus b square. If you take a look here, what I have is 1 times a square times b power of 0. And then I have here a power of 1, b power of 1. And for the last one, I have a power of 0 and b power of 2. So the power for a goes from 2 to 1 to 0. And the power for b goes from 0 to 1 and to 2. You can also observe for a plus b cubed, but I'm not going to do that in this video. So the second properties is that the power of a decreases by 1 in the successive terms, but the power of b increases by 1 in the successive terms. Okay, that is the second one. And now let's take a look at the third properties that we can get from our examples. So I'm going to use a different colored pen. I'm going to use the rainbow one. Okay, if you take a look here, for this line, okay, the total degree of A and B is equal to n. Whatever n I have here is equal to the sum of the degree for A and B. So in this case, my n is equal to 1. And if you take a look here, the power of A added to the power of b. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. Same as this one. Okay. In this case, my n is equal to 2. And if you observe the power for a and b and you add them up together, you are going to get still 2. Okay. 2 plus 0, 1 plus 1 and 0 plus 2 gives me 2, which is the same as the value of n. As for this line, my n is equal to 3. So, if we observe properly, then for each term, the total for the degree of A and B is equal to 3. So in the first one, a cube, b is 0. So 3 plus 0 is 3. This one is also 3. This one is also 3. The last one is also equals to 3. Okay, so I'm going to just conclude that here, the degree of each term is equal to n. Now, after we have find the properties, we can now proceed with the simpler method, which uses Pascal's triangle. So what is Pascal's triangle? I have drawn a triangle here. So again, we are going to start with n is equal to 0, and we call this as row 0. Okay, when n is equal to 0, we know that we are going to have only 1. Do you remember? A plus b power of 0 is only 1. Okay, so now for the next one, I'm going to have n is equal to 1, and we call this as row 1. So when a plus b is raised to the power of 1, we also know that our coefficient is 1 and 1. Why do we get 1? Now let's take a look here. Okay, from the first row, I can only go to that spot in one way. Okay, same as this one, there's only one way to reach that spot. What if from row 1, I need to move to row 2 where n is equal to 2? So for row 2, I can move from row 1 to this spot using only one way. So I have 1 there. So this is 1, and I can also move to that spot using only one way. So again, I have 1. But what about this spot right here? So that spot can have 2 different ways. One from the left and one from the right. So that is why we are going to get 2 here. 1 plus 1 is equal to 2. What about when I have n is equal to 3, my next row, row 3? So in this row, what I'm going to have is 1 on the left and 1 on the right. Again, I have 2 different spots to fill in here. And to get to those 2 spots, I need to move here. Okay, so for those 2 spots, the value are 3 and 3, because 1 plus 2, 2 plus 1. So both is 3. Okay, so now let's take a look at n is equal to 4. When I have n is equal to 4, I need you to pause this video and try to fill in the row by yourself. Okay, so for row 4, I will now have 1, and then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and I can only have one way to go to that spot. Okay, up to that. Now let's take a look at the question that I leave earlier. A plus b is raised to the power of 4. How do I get this expansion? So the answer is that we are going to use Pascal's triangle, because Pascal's triangle gives us the coefficient of our terms in the expansion. And then we can also use the properties that I have written here to determine our solution. So how do I start? A plus b raised to the power of 4. Now let's take a look at row 4 here. I know that my coefficient will be 1, 4, 6, 4, 1. And again, that one is symmetrical. So I just write 1, 4, 6, 4, and 1. And then what I need to do is use the properties. The second properties, the power of A decreases by 1. Power of B increases by 1. So power of A will start with the highest power, which is 4 here. And I will have A power of 4, A cube, A square, A to the first, and A power of 0. Now, what about B? B will start with the lowest power, meaning B power of 0. So B power of 0, B to the first, B square, B to the third, and B power of 4. Now, what do I do next? These terms should be added up together. You can refer to the expansion we did manually. So all the terms are added up together, and we can just simplify this. B power of 0 is equal to 1, and I know A power of 0 is also 1, so I can just rewrite that for our final answer as A power of 4 plus 4A cube B plus 6a square b square plus 4ab cube plus b power of 4, and I get my final answer.